All right, welcome to this video with Ray Tomes from the Cycles Research Institute. We're going to be talking about 9 climate pressure oscillation indices. Ray, what do we have on the screen here?
There's people have probably heard of one of the most common ones of these is called the Southern Oscillation Index. Let's just describe what that one is. It's a system that exists over the whole South Pacific. Mm-hmm. In fact, it radiates really over the whole Pacific, but mainly the South Pacific.
Yes.
And it's a pressure difference between Australia and South America.
Okay.
New Zealand will tend to be similar to Australia. So the pressure system will sometimes be up a bit at one side, down at the other, mm-hmm. and sometimes the other. Now, of course, it's changing all the time, but this is a prevailing condition.
Yes.
That persists for a year or 2 or 3 at a time. Mm-hmm. The result is that the winds flow in a particular way, predominantly at certain times, and at other times they flow the other way.
Okay.
And in South America, this is called El Nino or La Nina, depending on which phase it is.
Which way it's blowing.
Yeah. Mm-hmm. And one of them gives them nicer weather, and one of them gives them rotten weather.
Yeah.
So that's just one of these, the Southern Oscillation Index, this mustard coloured one here. And we can see this is ranging, the graph ranges from 1850s through to 2010. We can see that it spends a year or 2 or 3 on one side. Usually it's returned 2, 3, 4 years later, 5 years later, it comes back around again.
Yes.
So it's not a regular cycle. So we can't really call this a cycle. We call it an oscillation. It
doesn't really have periodicity.
It doesn't have periodicity. No, it's pretty hard to predict because it's like a swing that somebody's standing up on, sitting down on, hanging off the bottom of. So it's swinging at different rates all the time, right?
Bit eccentric.
There's a bit of activity happening on the swing,
okay.
And so it's not regular. If it's out one side at one stage, you can say probably it's going to be out the other side relatively soon. So it is possible for them to predict a year or 2 ahead. It looks like we're going to have this phase of the Southern Oscillation this coming summer.
So it has some balance, but not predictability.
Not a long way ahead anyway, just a little way ahead. And there's a variation amongst these ones here. So the ones that we've got, each of them has a little 3-letter name and a description. And these ones are referred to variously in papers in the literature and attributed different things to them. So we've got Atlantic multidecadal oscillation.
Yes.
So the multidecadal tells us that it exists for a period at a time in one direction. So we can see here that it comes down, comes up, comes down, comes up, and you can see there's something approximating a 60-year cycle. It's low here, about 1920, low here again, about 1970, 80,
yeah.
And high here and high here. So this one, we do know there's particularly in the Atlantic, North Atlantic, there's the flow of the currents in that there do have the 60-year fluctuation in them. And we do know also that the global temperatures have a 60-year oscillation in them. So they were relatively high around 1940, relatively low in 1970, high again around 2000.
Yes.
And we can trace that back a little bit. So that this 60-year thing does manifest in a number of different things.
It seems to be in phase with that 60-year.
Yeah, it is.
description.
Yeah, it is. Yeah. So that's one. North Atlantic. I'm going to typo there. North Atlantic Oscillation.
Mm-hmm.
That one's a shorter term one, right?
This one in purple, yes.
Yeah. We've mentioned the Southern Oscillation. North Pacific Index. This one here.
Bright blue.
Yeah, and you can see that's looked like very much like an annual thing, although there seems to be a little bit of modulation in it also. Pacific Decadal Oscillation.
In Fuchsia.
So this one again has got a longer term one, and maybe that's also 60 years. Slightly different phase to that one, almost opposite but not quite.
Yes.
Quasi Biennial Oscillation. Now this one,
in blue.
it's a little bit of fuzz at the start, but we can see it's doing a cycle, a quite regular cycle. We'll have a look at that one in detail, of a little over 2 years. It's,
yes.
And so it's called Quasi Biennial, which would mean almost 2 years.
Mm-hmm.
Arctic Oscillation Index. Again, this one we've got some yearly ones, but we can see that it's at times it's a bit more up and a bit more down.
It does.
So there's a little bit of longer term as well.
Could that possibly be more than one cycle.
Yeah, all of these things probably got more than one.
Yes.
But that one's got one fairly dominant one, and a couple of others.
And
some
the
of these
green one
others
is showing signs of that.
And some of these have got a very clear yearly cycle in them as well.
Yeah.
North Tropical Atlantic Index.
In red.
So it's wandering around a bit. It's got a bit of it doesn't stay all in one place. It's somewhere between things like the Southern Oscillation Index and these really long-term ones. And the Antarctic Oscillation Index, again, there's a bit of trends in that. So we can look at these individually. We've got this might serve as an interesting exercise that we will use when we look at the CAT software. We can bring these up. This graph was produced using the CAT software, and we'll perhaps look at the relationships between them and so on.
Yes.
So one of the things I've done here is look at to what extent they're correlated to each other.
Yes.
So we can take any pair here, like the Southern Oscillation Index, we can say and compare it to the PDO, and it has a minus 0.39 correlation. That's a moderate negative correlation. There's a couple of very high values in here. NAO with AOI, we can say there's a 0.65 correlation. In other words, they're measuring something pretty much the same thing, and again AMO and NTA are measuring pretty much the same thing. So although we've got 9 different things there, there's probably really only 6 or 7 totally different things if we separate them out. If we
A
do
lot of
factor
data
analysis.
points from 1951 to 2009, so it's going to be interesting for further analysis.
Yeah. This is the black graph is the Southern Oscillation Index, which is one of the most important ones because it has quite a big effect on global climates, and particularly Pacific and South Pacific ones.
Yes.
So this is a 7 cycles fit. I haven't put the periods of the particular cycles. It would be possible to check this to see whether it did any good. I wouldn't have a lot of confidence in any projections made with this one. It's you don't get a very good fit, you don't get very clear cycles in it, but there are some, and we can try that and do that and see.
Yes.
But you can see there's a lot of movement other than what's showing on that. This is the Quasi Biennial oscillation.
Yes.
And looking at that, we've got the data from before 1950, but the first couple of cycles are pretty messy, and one wonders whether that's really whether it really did that, or whether perhaps it took a little while before the measurements were consistently good enough. Because since there, it's been pretty regular.
Yeah.
And,
yes, it has.
So this is a fit of the strongest cycle in it, which is 2.346 years, or 28.15 months, to it, and we can make a projection. Now in this case I'd have quite a lot of confidence in the projection of that one because it fits. It fits well, and occasionally it's a little bit early, a little bit late, but it never gets far off that and it comes back again.
Phases back.
Yeah. So I would think that you can project that a reasonable number of years ahead and have some confidence going to do something like that.
Seems reasonable.
Yeah. This is a very interesting one. This is an autocorrelation of the QBO against itself at different lags, and we've done it out to 600 months, so 50 years. Now, commonly when we do this with a cycle, what we will see is the oscillation of the period that's there, and this will gradually reduce, sometimes with a couple of increases and decreases again, but usually by the time you get out that far, it's all damped off.
Yes.
In this case it hasn't.
No.
Now what this says is that whatever mechanism is driving this is very regular, that after 50 years the phase is still consistent with no wanderings about from there. So it's a fairly unusual one in that extent, and one almost wonders whether this has got some external cause.
Yes.
That's got a clock in it, but if it hasn't, it's got a very regular clock. No one's jumping up and down on the swing.
Okay.
Yeah.
Now, have you found other cycles and other things of this duration that seem to be relevant in any way?
There's there are a bunch of cycles a little over 2 years. Dewey mentioned 2.22 years as a common one. It gets a little bit complicated because there are some other things that are not that far apart, and you need a longer period to resolve them.
Yes.
I think there are some others of that period, but there are a bunch of other periods between about 1.96 years in this figure. There may be 3 or 4 different cycles that appear, so we need enough data to be sure. I mean, this one we've got an accurate period.
Yes.
Not all of the others do we always have, but in climate there often seems to be things around that period.
Yes.
This is the spectrum of the QBO, and we can see there's a clear 6-month cycle and a clear 12-month cycle. They're both significant, but not highly so.
Yes.
So there is a 1-year component in there as well as the near 2-year component, and there's a period just under 2 years. And I mentioned Dewey mentions a 2.22 year, so this is pretty close to that 2.211 years. So that's probably the cycle that he's got. And then we've got this 2.346 years, which is very highly significant, 0.0004.
Yeah.
So we can say this is a very real cycle.
Surely.
It's very regular, and
Yes.
it runs pretty much like clockwork.
The Quasi Biennial.
Yeah, Quasi Biennial oscillation. Yeah.
From 1948 to 2010.
Yeah.
Right, you are.
So that's the summary of those ones. We've only looked at a couple of them in detail, but we've got the data of all of these, and we could, at some point, let's do a CATS. We're going to do a review of the CATS software, how to use it and do things.
Marvelous.
And let's use these ones as an example to show the sort of things that we can do with them, and we can look to try and measure these 60-year cycles and see how long. I should mention with the 60-year cycles, a lot of the climate stuff that we've already looked at have shown that when we do a spectrum of very long-term stuff, there often shows multiple different cycles in the range 55 to 60 years. So it's not a stable cycle like this one is.
Yeah,
well, this is stable over this period. Who knows what it does on longer periods? But the cycle's genuinely there, but the period of it wanders around a little bit, and the phase wanders around a bit. We saw the same thing with the 11-year sunspot cycle. It's always there.
Yeah.
You don't have any trouble saying, yeah, that's a solar maximum, that's a solar minimum, although sometimes it nearly died out. But over the long period, we saw the phase wander around by 3/4 of a cycle. So sometimes the dips where the trough should have been, so on. This one's not doing that. It's doing that. So those are interesting aspects of cycles that we see on different occasions. And the yearly ones, we can see there's a strong yearly cycle in a number of these. The phase of that's not going to wander around. The year is pretty regular.
Yeah.
And so and these things are going to be followed. It's the heat of the sun and the tilt of the Earth's axis and so on. Those things are going to be working to make those ones. They should run like clockwork. You know when the seasons are going to be in 100 years' time. You don't have any doubt about that, unless we're going to get hit by a massive asteroid or something that comes hurtling in from space. That's going to be continued to be the case.
Yes.